All right, hi boys and girls. What I'm going to do now is we're going to go back over the vocabulary that was in the first video, and you can take some notes if you like. Notice my quarantine nails all gone. I had to take all my acrylics off. Oh, it's so sad. Okay, and what we're going to do is you can take these notes. You won't have to turn in your notes to me, but what you'll do is you'll fill in a Google form to show that you know the definitions of these words. So you have to type something and send it to me. But let's start off with some of the vocabulary. First word is force. Now, do you remember what a force is? A force is a push or a pull. All right. Anytime you push something or pull something, you are applying a force. All right. The next word that was in the video is this word that looks like inertia, but remember, it is not inertia. It is inertia. Say inertia. All right. Almost sounds like a girl's name. All right. Inertia. Inertia is also known as Newton. Remember, we said in the other video that Sir Isaac Newton is a scientist who discovered, by doing a lot of research, laws about force and motion. Newton's first law, which is literally the law of inertia. All right. Inertia is the tendency. A tendency is like a thing about something. Like Miss Godfrey has a tendency to be really nice and then all of a sudden just not be that nice anymore and then apologize. Say that's a tendency about me. All right. A tendency is something that kind of describes something about the way that they usually are. So the tendency of objects to resist change. Now, resist means to say no. So if I'm resisting, I'm like, no, not going to happen. So an object like a soccer ball that is just sitting somewhere is going to continue doing what it's already doing unless you apply a force. So the tendency of objects to resist change. We can say, to resist change. All right. So the way Newton created the law, it's worded something like this: an object at rest remains at rest. Right? At rest means just not moving, and remain means to stay and keep doing what you're doing. And then the other one, an object in motion remains in motion. In other words, something that's moving is going to keep on moving just the way that it is until here it is. Until a force is applied. Meaning, for that objects want to keep doing what they're doing. And the only way to stop an object from doing what it's doing is to apply a force. All right. Now, the next thing I want us to talk about is two different forces that can change the motion of objects. One is friction. We have friction. First of all, let's tell you what friction is. Friction, and the way I say it to make it real simple, is when matter rubs against matter. And the way I always do it is just like this. Now, in our atmosphere, no matter what you do, when you kick a ball or throw something, it's not going to keep going forever. Even though Newton's first law says that things would go on forever, they would keep moving because that's inertia. Inertia is a property of matter. That's what it says at the beginning of every Bill Nye video. And inertia means that things want to keep doing what they're doing. So technically, something that you throw should go on forever if there were no forces applied, if there were no forces in order to stop it. However, we have forces in action all over our Earth. Friction, there's this thing called air resistance. Resistance. That's when you throw something, it's always matter rubbing against air, which is also matter, which will slow things down. That's one type of friction. And then, of course, there's friction whenever anything touches anything. If you kick a ball on the ground, it's rubbing across the ground. That will slow it down too. Now, the other force that is always in action on our world is gravity, which we mentioned in the other video. Gravity is the force that pulls things down, down, down to the earth. Now, when I was talking to you about this in the other video, I was talking about how how things get pulled into the earth. I want you to think about this. I'm not going to draw the earth as a sphere, but as a circle. And imagine that there's space all around it. So if you're like a meteor flying out from space and you get caught in the earth's atmosphere and in the earth's gravitational pull, watch what would happen. It would get pulled into the earth. If you were a different space rock over here, you would get pulled into the earth. If you were a different space rock over here, you would get pulled into the earth. If you are another space rock over here, you would get pulled into the earth. Now, the earth is pretty massive, so it has a pretty big gravitational pull. However, the sun is even more massive and has an even bigger gravitational pull. So the mass of the planet or the body in space is proportional, meaning that if you're bigger, you have a stronger gravitational pull, and if you're smaller and less massive, then you would have less of a gravitational pull. All right, so the Earth is massive enough to keep the moon orbiting around it with its gravitational pull, but not big enough for the planets to orbit us. They continue to orbit the sun. All right, and there was one more word that I would maybe want to bring in here, and that was a Newton. You won't see this very much, but remember, Sir Isaac Newton is the person who found out about the laws of motion, and a Newton is a unit of force. Just like a centimeter is a unit to measure length, or a kilometer is a unit to measure distance, or a pound or a kilogram measures mass. A Newton is what will measure force, a unit to measure force. All right, and we're going to stop there. Now, when you're finished with this, you need to go to the Google form and you need to complete the vocabulary activity. Love you. Mean it.